Assalamualaikum and hi. My name is Muhammad Amir Syahmi bin Sallehuddin. I am from RK23. So this is video presentation 4. In three-phase system, the three-phase can be connected in either star or delta configuration. Readings of a three-phase transformer can be connected in various ways of configuration such as star to star, delta to delta, star to delta, and delta to star. In any of these configuration, there will be a phase difference of 120 degree between any two phases. This project consists of three-phase star-connected generator, transmission loss, and a load with acceptance power factor lagging according to Electricity Supply Application Handbook V3, ESA V3. Every branch of a balanced three-phase star-connected transmission loss and the load possess a resistance and a reactance respectively. In addition, star-to-star connection is generally used for small high voltage transformers. Because of the star connection, the number of turns of phase is reduced. Thus, the amount of insulation required is also reduced. The ratio of line voltage on the primary side and secondary side is equal to the transformation ratio of the transformers. Line voltage on the both sides are in the phase with each other. This connection can be used only if the connected load is balanced. We go for our objective. The objective of this project or experiment are to evaluate the parameter of electrical system in context of transmission and load impedance, currents, voltage, and acceptance voltage drop in any nation authority standard. Second, to evaluate and analyze the active power absorbed by the loads by using 2 wattmeter method and the conventional measuring method. Third, to justify the normal operating condition of the electrical system and validate the study with simulation. The important in this project is showing step by step of the procedures and methodology to develop and designing in finishing for the project. It is to make sure the project successfully during the progress. A flowchart is an important process which is the following the flowchart. This project is able to orderly flow and clarity. So we go to our flowchart. Before I start with the flowchart, I want to tell that this project is using PC software to run the circuit simulation. And we go to our flowchart. So refer to our flowchart. We can see that it's starting with the start and go to the statement. Draw the circuits of three-phase transformer Y to Y connection using PC software. This is why I tell that the simulation is using PC software. And after draw the circuit using this software, insert the value of V line, frequency, loads, and transmission. So the frequency is, we refer to ESA V3 frequency that from the handbook give. So the frequency is 50 Hz, and the transmission loss and the load is given, refer to our metric number. So after that, we go to the next statement. Simulate the circuit to obtain the result of V phase, V line, I phase, and I line. So if we did not get the result for V phase, V line, I phase, and I line, we repeat the process. And if we got the result for this V phase, V line, I phase, and I line, we go to the other statement. Add 2 wattmeter at the circuit to find the active power absorbed by the loads, and also using conventional method to obtain the same purpose. So for this statement, we add 2 wattmeter. This is the 2 wattmeter method to find the power absorbed by the loads, and also using conventional method to find the power absorbed by the loads. So these two methods is to find the same purpose. So we go to another statement in this flowchart. Simulate the circuit to obtain the result of power absorbed by the loads. So for this statement, we know that if we get the result for the power absorbed by the loads, so we can go to the another the simulation is done. But if the result we did not get, so we repeat the simulation until we get the result power absorbed by the loads. So that's it for the flowchart. Go to the circuit diagram of the project. So I will tell the value that given to me. So the V line, voltage line for this simulation is 275 kilovolt. The transmission loss value is 43 plus J10 ohm, and the value for the load is 91 plus J9 ohms. So this value is given to me to use in this project. So we go to the circuit diagram. So we go for our circuit diagram. So this is the first circuit diagram. So it is a simulation of 3-phase transformer with Y to Y connection using PC software. The result that will come out from this simulation circuit is phase voltage, line voltage, and line current for both sides. So I want to tell you that for value of transmission loss and load, I use resistor and inductor. So the value of resistor, I just input the value into the resistor, and for the inductor, I need to convert using 2πfL formula, because the software cannot read the imaginary value. So if you can see from this this value of inductor, it's already converted using 2 pi FL formula. So we go to the next circuit diagram. Okay, this circuit diagram is the simulation circuit of 3-phase transformer with 2 watt meter. So basically this is the circuit using 2 watt meter methods. So the result that will come up from this simulation circuit is total active power that absorbed by the loads. Result that I already got from the circuit simulation is V phase, V line and I line for both sides. So this result I will compare with my calculation. So for V phase, for primary side, I label with V1, V2, V3. These three come up with the same result, which is 158,771.32 volt. So for the V line also come up with the same result. The label is VAB, VBC and VCA capital letter. The result is 275,000 volt. And for the I line primary side is the label is I1, I2, I3. So the result for I1 is 1559.09 ampere, I2 1323.961 ampere, for I3 1227.16 ampere. So we go for V phase, V line and I line secondary side. So the label for V phase secondary side is V4, V5 and V6. So for the V4 is 90,891.268 volt, V5 99,366.378 volt, V6 98,568.4 volt. So for V line secondary side, the label is VAB, VBC and VCA with the lowest letter. So the VAB 162,954.2 volt, VBC 175,833.98 volt, for VCA 161,493.74 volt. So the I line for secondary side that I label is I4, I5 and I6. So for I4 993.12 ampere, I5 1054.13 ampere, I6 1043.65 ampere. So this is the result that come out from the circuit simulation, and this is the waveform for both primary and secondary side. I say for the voltage drop that I already calculated for this circuit is 32.43%. So the voltage drop between primary and secondary side is 32.43%. So we go for the next circuit simulation, which is circuit simulation with 2 watt meter methods. So this is the waveform that I got from the circuit simulation, and the total power that absorbed by the loads is 580.34 megawatts. So for what can I discuss from this result and the calculation is the result for simulation and calculation is not too far, so we can assume that the simulation is successful, and I will discuss little bit for this project. Need to construct Y-to-Y connection between three-phase generator and loads. So need to run and get the parameter result of electrical system, which are phase voltage, line voltage, current, line current, and line phase. In additional, after already done with the first circuit simulation, we go for the second by adding 2 wattmeter in the circuit using 2 wattmeter methods to get the power absorbed by the loads, and also using conventional methods to get the power absorbed by the loads. So the result from the simulation are not too far with the calculation, because when using simulation, it has a difference between calculation and simulation. So the difference is not too far. It has a little bit error for simulation or practical. By doing this project is known to make a three-phase Y-to-Y connection and identify the parameter of electrical system in the circuit connection. So this project that make a student know to make a Y-to-Y connection for electrical system and get the parameter from the circuit simulation using PC software. Okay, next, the parameter was successfully analyzed, and the result between calculation and simulation is not too far. That is I already talked before. The calculation and simulation for both sides, the result for both is not too far. Furthermore, knows the way to get the result using 2 wattmeter and conventional method. So student know to how to get the result using two methods, which are 2 wattmeter methods and conventional method to get the power absorbed by the loads. Lastly, completely justified the normal operating condition of electrical system to increase the knowledge about the operation of the electrical system. So what can I say for this is the circuit simulation is justified for the normal operating condition of electrical system. So that's all for me. Assalamualaikum warahmatullahi wabarakatuh.